the other one is you need to know something about moles and gases. ठीक है, वो मैं add करूँगा. So moles and gas volume, you know that 1 mole of gas occupies 24 dm cube, ठीक है? But this time, unlike O levels, you always assume that it occupies 24 dm cube. In A levels, you're not going to assume. As long as it's not written explicitly that the thing is happening, the reaction is happening at room temperature, you're not going to assume that. I mean, in this case, we're going to assume that it will occupy 24 dm cube. So the question states that there is 50 grams of sodium azide. Can somebody tell me what the moles are? How do you find moles? Mass divided by? So you got 50 grams, and that particular mass would be divided by the MR of sodium azide, which would be 23, plus there are 3 nitrogens. So that's 14 times 3.
65, and 50 over 65 is 0.76.
769.
7. Use 3. You can use 3. So 7 because the value is 1 second. So 7 and 7 moles, right?
Yes, sir.
So he's saying calculate the volume of nitrogen gas that's produced. So nitrogen is over here. So you have to calculate the volume of this thing. So it's 2:3, right? So what would you get? 0.77 divided by 2 into 3. What do you get?
1.15.
That's a 1.15 moles, okay? So you found the moles of N2, and the only thing is you have to find the volume. So to find volume, moles are going to be multiplied by 24. So it's going to be 1.15 multiplied by 24 dm cube.
27.6.
20.
Okay, so C?
Yes.
Yeah, see.
Okay. And always be careful. Is he talking about CM cube or DM cube? Be careful about the units. They're going to try and confuse you with the units as well. So always keep your eyes open is it the same unit or not. I said now the next one is that's easy. You just have to balance the equation, and he's saying which one requires 2.5 moles of molecular oxygen. So we can just balance oxygens for combustion. I mean, this is complete combustion. So it's going to form carbon dioxide and H2O. And you've got 2 carbons over here. So there would be 2 carbons on this side over here as well. And you've got 6, that would be 3 water molecules. So the amount of oxygens would be 4 plus 3, that's 7. There's 1 already in the molecule. So over here, it's going to be 3. So the first one is wrong. Again, you can do this for the other ones as well. He's asking for which one requires 2.5 moles of molecular oxygen. So next one, let's move to the next one. Which mass of gas would occupy a volume of 3 dm cube at 25 at 1 R? I mean, this is RTP, and he's already told you that it is 24 dm cube at RTP. So how many moles is this? This is 3 divided by 24, which gives you 1/8 or 0.125, I think. So you get this value. Remember, if the gas has the same moles, it's going to occupy the same volume. So he's saying which mass of gas would occupy this volume. So you would have to calculate the moles for each one of them. So any gas that has 1/8 moles or 0.125 moles would occupy this volume, 3 dm cube. Okay, I calculated that.
C.
Okay, any quick question? Huh?
Sir, C.
Okay, C, right?
Yes, sir.
Yes, sir.
8 divided by 64, because 8 is the mass and 64 is the MR, 32 plus 16 plus 16. And that would give you 1/8 moles or 0.125 moles. So that would also occupy 3 dm cube. So that's the answer. C is the answer. As a rest, I mean, most of the other questions are kind of the same. For example, this one. I said, now let's look at this one. This one is an interesting question. Remember, you don't need to know the whole equation. to
Sir?
figure out. Yes.
Nothing. Sorry, I was mistaken.
अच्छा, so पिछला मैंने वैसे ही skip किया क्योंकि वो pollutant से ऊपर है, ठीक है, I don't want to go into that right now, ठीक है. अच्छा, this one. Now the question is, you've got aluminium powder and anhydrous barium nitrate. And अच्छा, remember, to find out the ratio in the equation, you don't need to know the whole equation. So read carefully. There's aluminium reacting with barium nitrate. So it's aluminium reacting with barium. I mean, this is aluminium reacting with barium nitrate. Ba is in group 2, so it's BaNO3 twice. And he's saying that it's used, the metal oxides and nitrogen are the only products. So there's a metal oxide. I mean, in this case, it would be aluminium oxide. And it would be barium oxide. And nitrogen are the only product. And it's going to be N2. Now, if you try to balance the whole equation, that would take you ages. I mean, right now you don't even know how to balance this one. I've not taught you how to balance this. I mean, this equation is really hard to balance. There's a different method of balancing that we'll study later on. It's redox balancing. Reactions that are redox reactions, they need to be balanced in a different way. But we'll talk about that later. But what if you don't want to spend time on balancing the equation? So what would you do? He's asking, what volume of nitrogen is going to be produced under room conditions if 0.783 grams of barium nitrate reacts? So we are only interested in this ratio. Like barium nitrate reacts, what is the volume of nitrogen gas that's going to be produced? So I'm not interested in the ratios of the other substances. I'm just interested in their ratios. So let's assume, because we don't care about the other substances, we don't want to do any calculations for these other substances. So let's assume that they don't exist. What do you think would be the ratio? Is it going to be 1:1? Like you've got all the nitrogen atom over here is coming from barium nitrate.
Yes,
so that means if you have a molecule of barium nitrate, it's got 2 nitrogens. So the ratio is going to be 1:1. So forget all the other balancing. Just find out what would be the ratio of, because of the nitrogen atoms, only the nitrogen atoms. There are 2 nitrogens here, there should be 2 nitrogens over here as well, which makes it 1:1. So that's, you figured out the ratio, without balancing the whole equation. But the actual equation mein ho sakta hai ki it comes out to be 3:3 or something else. Like I can like aluminium with, one second, barium nitrate reaction. So iske andar this is the reaction, theek hai? And I'll show you the balance equation. That's going to be a very difficult balance equation if it opens up. Just a second. Achha, so neither. Achha, this one. So where's the complete? Look at this. It comes out to be 10 aluminium, 3 barium nitrate, 5 Al2O3 and 3. So it's, but at the end of the day, look at the ratio of barium nitrate with nitrogen. It is 1:1. Okay, so we're not going to spend time wasting and trying to balance the whole equation. Okay, that's going to be a huge waste of time. All I wanted to know was what would be the ratio of barium nitrate to nitrogen, and it's going to be the same ratio.
Sir?
Yes.
Right now, you know that it's 1:1. For example, if we don't know it's 1:1 because we haven't even balanced it, then are we going to assume it or what?
No, I'm not assuming it. Ye dekho ke yahan pe how many nitrogens do you have? 2, right?
2, yeah.
And is there there's no nitrogen anywhere else, theek hai? Yahan pe to nitrogen nahi hai na, theek hai? So yahan pe how many nitrogens you've got? You've got 2, right?
2.
Uska matlab hai it's impossible ke inka ratio kuch aur ho. It's impossible.
Mhm.
I mean, this would not be possible just because of the nitrogen atoms.
Mhm.
Because now you've got 2 over here, you've got 4 over here, so that's not possible. So assume nahi kare, and remember it's only the nitrogen. Because of the nitrogen, I'm able to figure out the ratio without balancing it. Because if I had tried balancing oxygen, the oxygen to aur jagahon pe bhi hai na, so I couldn't figure out the ratio using oxygen, right? Is this clear?
Mhm. Yes, sir.
So इसलिए we're not assuming it. We just it's a good guess. ठीक है, it's 1:1. It's going to be 1:1. अब काम आसान है, ठीक है. So you haven't wasted time balancing the equation. You just figured out the ratio directly. And अच्छा वो balancing होनी भी नहीं थी, ठीक है. Even if you had tried it, it would have been kind of impossible unless you have to learn something extra for that. अच्छा, so you've got 0.783 grams. Find out the moles. कितने moles है?
Sir, 0.00300.
कितना? 0.
0.00300.
Okay, those are your moles. And correct 2 3 significant figures, okay, because this value was 3 significant figures. So N2 moles would be exactly the same. And you have to find the volume. So just multiply by 24, you'll get the volume, which would be what?
72.
Okay. And remember, iska khayal rakhna ki he's now talking in CM cube. You'll get in DM cube. Okay, you'll get, I think, what would you get?
Sir, I wrote 24,000. I converted it into CM cube already.
Okay. I said, just be careful with the units. I said, next one is this clear? The previous one?
Yes, sir.
I said, the next one is you've got 1 mole of each of the following compounds is strongly heated. I said, remember carbonates, we did decomposition, right? So you should know, okay, it's carbonates, nitrates, and hydroxides. These were the 3 elements which we decomposed. Carbonates would decompose to form oxide plus carbon dioxide. Nitrates would decompose to form oxide plus 2NO2 plus half O2, and we did hydroxide decomposition as well, which would form oxide plus water. So he's saying for which compound is 24 dm cube. Now there's 1 mole of each compound, 1 mole of this, 1 mole of this, 1 mole of this. Ye pehla wala jo hai, that is not going to decompose. So that's out of the question. Wo waise hi galat ho gaya. So he's saying for which compound is 24 dm cube of gas, and remember it's all room temperature. So this is also gone because at room temperature there is no gas. I mean both of them are solids. Okay? So the only decision you have to make is which compound would give you 24 dm cube, which is 1 mole. So it's going to be this one. This one would produce 1 mole of CO2 gas. 1 mole would produce 1 mole of CO2 gas. Yahan pe the amount of moles would be a lot more. Okay? So is this clear?
Sir, can you explain one more time?
Yeah, he's saying they're strongly heated. When you strongly heat substances, they decompose. Now, when we were doing equations in class, we wrote down a lot of equations, right? And we wrote down decomposition equations. There were 3 substances, nitrates, hydroxides, and carbonates, whose decomposition equations I wrote down. Carbonates would form this thing. Nitrates would form oxide, NO2 and O2. Hydroxides would form oxide plus water. The first one will not decompose. And he's asking for which compound, if 1 mole of a compound is decomposed, that's the question. 1 mole of each compound.
So why doesn't it decompose?
Did anyone ask a question? I couldn't hear you. So 1 mole of each compound is decomposing, and everything is the gases are collected at room temperature. So over here, there would be no gas. Okay, this is a liquid at room temperature, and this one is a solid. So you can cut that out. So he's asking for which compound is 24 dm cube of gas likely. So which one is going to be making 1 mole of gas? So it's going to be this one. It's 1 mole of gas. Over here, the amount of gas is 2.5 moles. So that's a lot more. So is this clear?
Yes, sir. Thank you, sir.
Achha, ab aa jao, this one. So this is a question I wanted to discuss. So this is another type of question. I'm going to discuss it on the board. 1 second. I said this one, we were doing moles here, I think. Just 1 second there. I said we did all the basic mole stuff here. So this one is another tiny small concept. So gas volume and mole ratio. Now the concept is, so the concept is that, for example, you've got gases reacting with each other. So I've got H2 gas, and it's reacting with O2 gas, and it's forming. Let's assume H2O is. I wanted gases. Just a second. I'll do the Haber process. So let's say I've got N2 gas reacting with 3H2 gas, and it's forming 2 NH3 gas molecules. What's happening here is that you've got 1 mole of N2 gas. Remember, all of them are gases. I mean, that's a condition that we're just comparing gases. So if a reaction has only gases, so this doesn't apply to solids or liquids. So 1 mole of gas reacts with 3 moles of gas and produces 2 moles of ammonia gas. And let's say it's actually 1 mole of gas that's reacting. So what is it? It's 24 dm cube of gas reacting with how much? 72 dm cube of, like 3 moles of gas is 72 dm cube, and producing 48. What is 2 moles of gas? That would produce 48 dm cube. So is this clear so far?
Yes.
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 Achha, now when you're comparing gases in an equation, remember this, that the mole ratio and the volume ratio is exactly the same. Like 1:3 is the same ratio as 24:72. Is this clear?
Yes, sir.
Yes, it's clear.
So remember this for gases, like if you have 2 gases in an equation, their mole ratio and volume ratio is exactly the same. So their mole ratio and volume ratio are exactly the same. So that means I don't actually have to do a calculation. Like if I have 10,000 cm cube of N2 gas, तो मुझे directly बता दो कि I don't have to convert that into moles. I don't have to do the whole moles calculation. 1 reacts with 3, so 10,000. If the volume is 10,000, what would be the volume of H2 gas that would react with it?
3,000.
30,000.
Yes,
Right.
I meant 30.
And the amount of NH3 that would be produced would be 20,000, right?
Yes.
Achha, so that's a simple point. Like you don't have to calculate moles. I mean, why calculate moles when you can directly just answer it? So and this only applies to gases when gases are being compared. You don't actually have to calculate moles. It's you find the moles of one gas, you can find you find the volume of one gas, you can find the volume of all the other gases as well, just directly. Just use mole ratio. For mole ratio,
Sir,
yes.
why not for any other state? For liquid or for
नहीं,
solid?
उनका volume ही different होता है ना. That I mean, for example, if मतलब उसका volume वाली term apply नहीं होती ना to a solid, right? To it, every solid has a different density. कुछ के अंदर atoms ज़्यादा tightly, तो इसलिए उनमें mole ratio and volume ratio is not exactly the same. ठीक है? क्योंकि अगर atom छोटे होंगे तो the same volume you could have more atoms in it, right? So उस case में volume ratio and mole ratio would not be the same. I mean, I can explain that just a bit. Okay, I've got one solid and I've got another solid. Okay. So the thing would be that if you could have one solid with bigger atoms. And let's say the other one has even bigger atoms. Okay. So the point is, I mean, the volume ratio is the same, but the moles, I mean, this has a lot more moles, this has a lot lesser moles. Is this clear? Okay. Achha, for gases, it doesn't matter. Because gases when you take the volume of a gas, what you basically have is empty space. Like most gases is just empty space. So because they're never tightly packed, it doesn't really particle ka apna jo volume hai na, that is insignificant. Like you would have a tiny particle. So 4 particles are occupying this much volume at RTP, right? You could have 4 other particles. They could be slightly bigger in size. And they would still be occupying the same volume at RTP. So because gases are mostly empty spaces, they expand when you increase temperature, they contract when you decrease temperature. Like in 1 mole of gas occupies any gas, whether it's this one, whether it has big molecules or it has small molecules. 1 mole of any gas would occupy exactly the same volume at room temperature and pressure. Okay, so the takeaway is that the mole ratio and the volume ratio would be exactly the same. So you don't have to calculate moles. So if I do this question now, I'm going to try and do this question directly. Okay. And he's saying that all of them are gases. Okay. So all of them, I mean, carbon dioxide is a gas, SO2 is a gas. And he's saying room temperature, right?
Right, sir.
Or one of which is methane thiol, which burns, it's exploded with 60 cm cube of oxygen. So 10 cm cube, this is the formula.
Then O2 will be 30
Okay, the O2 reacted would be 30.
and CO2 would be 10. Similarly, SO2.
SO2 would be 10 as well. Clear? Or water.
And H2O won't be in count, right? Oh,
okay. We won't, it's not a gas. Okay. So what is the final volume of the resultant mixture of gases? So he's only asking for the gases. Okay. So what is the final volume? So how much products have been?
50?
Achha.
20, sir, 20.
Nahi,
Option A.
it's better the first thing, products. How many products do you have?
20.
Achha, there are 20 cm cube of products that are formed, right? Achha, 10 would react with 30, so that's gone. 10 would react with 30 and produce 20 cm cube of products, right? But the amount of oxygen that he's adding is 60 cm cube. He's actually adding a lot more. The only 30 would react. So there's going to be 30 cm cube of leftover oxygen. Because if you look over here, he told us okay, 10 cm cube is reacting or exploded with 60 cm cube. You don't need 60 cm cube. 10 cm cube would only react with 30. So that means there's this extra 30 cm cube added, which is not going to take part in the reaction. So the final volume of the resultant mixture of gases would be, you'll have your products and you'll have the leftover remaining oxygen as well. Hence the answer would be 50. Is this clear?
Yes, sir.
Sir, so
Yes.
basically oxygen is in excess.
Okay, you just needed 30. You didn't need 60.
Okay, sir.
So that means 30 cm cube extra has been added, and that would also be present. So we'll do similar questions. Just let's do similar questions. This one. Now he's saying that 10 cm cube of carbon disulfide was burned in 50 cm cube of oxygen. So first thing, 10 cm cube. Without calculating moles, what volume of O2 would be required?
30.
Okay, so
30.
30 cm cube, and CO2 would be 10.
10 and 20.
And this would be 10, 20. So the amount of products that are being formed, that's 30. As I'm going to write this down, what do you have at the end? You've got CO2, which is 10 cm cube. That's produced. The CS2 and O2 have reacted. These are gone. You've got SO2, and the volume of SO2 is 20 cm cube. And what is the leftover oxygen? Because he added how much oxygen? He added 50 cm cube.
20 cm.
So 20 cm cube is left at the end. I said now the question is slightly, it has some extra steps. What he says is, I mean, this is your resultant mixture. This is what you have at the end. The question states, after measuring the volume of gas remaining, the product was treated with an excess of NaOH and the volume of gas measured again. So this is your product. This is everything that you have at the moment after the reaction. Can anyone tell me, now NaOH is added. NaOH is a base. Which of these gases would react with NaOH?
Sulfur dioxide. Carbon dioxide.
Both of them are acidic. Remember, carbon dioxide dissolves in water to form carbonic acid. Sulfur dioxide dissolves in water to form sulfurous and sulfuric acid. So both of these gases are acidic. So if you add NaOH, these two gases will be absorbed by NaOH. So the volume of gas after burning was 50. But once you pass it through NaOH, these two gases will be absorbed. So what would
It would be 20.
what
C.
would be left would be 20. So it's going to be C. So is this clear as well?
Yes, sir.
You can remember this from O levels, that non-metal oxides like carbon dioxide, sulfur dioxide, nitrogen oxides, phosphorus oxides, they were acidic. So the next one is similar. You've got, he's saying methane and ethane are burnt. So you would have to make the equation. Methane is CH4. If you don't know the formula of anything, just Google it at the moment. So it would form CO2 and water. And you have ethane as well, which is C2H6. And how many oxygens? That would be 4 plus 3, 7. So over here, it's going to be 7 by 2 or 3.5 moles of oxygen. You can convert that into a whole number by multiplying the whole equation by 2. But anyways, there's 10 cm cube of both gases being burnt. So you've got 10 cm cube of this, and you've got 10 cm cube of this as well. And everything was measured at the same temperature. Okay, so he's not explicitly, he's saying after cooling to room temperature. So it is at room temperature. So water is not going to be a gas. So he's saying what volume of gas was absorbed by the alkali. So carbon dioxide is the only acidic gas. So the first one produces 10 cm cube of carbon dioxide, and the second one produces 20 cm cube of carbon dioxide. So carbon dioxide is the only acidic gas in the whole thing. So the answer would be, what is the volume of gas that's burnt? That's that gets absorbed, and that would be 30 cm cube. Is this clear?
Yes, sir. Yes, sir.
So next is, I'm just trying to find out more questions like this. So just remember this, we'll just sum it up here.
Sir,
Yes.
sir, page number 11, question number 26. Can you do that?
This one, acha, theek hai. Isme bas issue ye, the mistake that you're doing is, he's saying which volume of oxygen measured at room temperature and pressure is needed for complete combustion of 0.1 propan-1-ol, right? If you don't know the equation, just Google propan-1-ol as C3H7OH. You react it with oxygen, and it produces carbon dioxide and H2O.
Water.
I said, so there's going to be 3 carbon dioxides and there would be 4 water molecules. And how many oxygens you've got? You've got 6 plus 4, 10. So there's 1 oxygen already over here.
9.
So there should be 9 over here. You'll multiply this by 4.5, right? So you've got 0.1 moles propanol. This is 0.1 moles. So ratio kya hai? It's 1:4.5, right? So 0.1, I mean 0.1 divided by 1 into 4.5, that would be 0.45. Is this clear?
Yes.
Yes, sir.
So just multiply it by 24 to find the volume and you'll get what?
10.8.
Okay, that comes out to be, I think, 10 point. Okay, 10.8 is probably the right one. Is this clear?
Yes, sir.
Yes, sir.
So we're done with this part section. Okay, try and ये फिर next assignment है कि
Sir, can you please follow up for 1 second so I can take a screenshot?
okay, just 1 second.
And sir, can you do question number 18 as well on page number 11?
Page 11.
Yes, the same.
ये वाला?
Yes, sir.
अच्छा इसमें बस वो कह रहे कि it's a Haber process. Let's quickly do that. N2 plus 3H2 and 2NH3, right?
Mm-hmm.
So he's saying कि there's 2 dm cube of nitrogen gas that's reacting, right? लेकिन आगे
Yes.
आगे वो कह रहे हैं कि it's only 15% of the nitrogen gas reacts. So it's not 2 dm cube, it's actually 15% of that. What is 15% of 2 dm cube? That would be 300 cm cube. Can you calculate?
0.3 dm cube.
Which is 300 cm cube, right? ठीक है. अच्छा, so the question is that only 15% of it is reacting. So that means 300 cm cube is reacting. And he's asking for the mass of ammonia. So what I can do is I can directly find the volume, which would be over here 600 cm cube, right? Or 0.6 dm cube. And because it's 1:2.
Mm-hmm.
And I can divide by 24,000, or if it's 0.6, how many moles would I get? 6 divided by 24, that's 6 fours, 0.25.
0.025. 0.025.
Okay, so it's 0.025 moles. That's what you're getting. And you can find the mass. Multiply the moles by the MR of NH3, which is 17. So 17 into 0.025, what?
0.425. Okay.
Okay.
Multiply.
So everyone, page up till page 11, do all the questions, TK, and I'll just make an assignment for that as well, TK.
Okay, sir.
Or make sure when you're doing this, you can either, the recommended thing is print this out and do these questions on it. I'll try and send the marking scheme as well. That's also missing at the moment. Or if you're doing it on a piece of paper, make sure you write the page numbers, TK, and the question number, like question number 9 of page 11. TK. So I know which question it is. So okay, then everyone take care.
Allah
Allah
Hafiz.
Hafiz.
Allah Hafiz.
Allah Hafiz. Allah Hafiz, sir.
Hafiz.